Today's video will be on equivalent equations. Okay, so our learning goals for today, by the end of the lesson you'll be able to identify and create equivalent equations, and your second learning goal is to be able to solve linear equations by creating equivalent equations and using inverse operations. Okay, so two equations are said to be equivalent if you can get from one side to the other by adding a number to both sides. It has to be the same number. Subtracting a number from both sides, again the same number. Multiplying both sides by the same number as long as it's not 0, or dividing both sides by the same number again as long as it's not 0. Or by swapping the left and right sides of the equation. So what does that actually mean? Well, as you can see here, 4 times 5 equals 20. So both sides of that equation are equivalent. So the left-hand side, 4 times 5, is equal to the right-hand side, which is 20. So we can still make them equivalent by doing different things. So if we were then to add a number to both sides, for instance, so if we had 4 times 5, but then we wanted to add 3, if we add that same number to both sides, they're still equivalent equations, because 4 times 5 is 20, plus 3 is 23, and that's equal to the right-hand side, which is 20 plus 3, which would be 23. So again, we could divide both sides by, 13. That would still make them equivalent equations because they're still going to have the same answer. So you can see we can modify both sides. As long as we're doing it to both sides, we're still going to have the same answer. Okay. So we can actually use this principle of equivalent equations to solve equations algebraically. So to solve an equation algebraically, what you need to do is you need to repeatedly find an equivalent equation that is simpler, and to do this we use inverse operations. So inverse is kind of just like the opposite. So for instance, 5x plus 2 equals 32. So if we want to solve that algebraically, we're going to repeatedly find equivalent equations that are simpler. So when we're solving anything algebraically, I like to do what we call is the onion method. This helps me work out where to start. So when if you've got 5x plus 2, where do you start? This method will help. So what we want to find is our value of x. So that's like our center of the onion, and we're going to work our way out through the layers. So what happened to x? Well, it was multiplied by 5, and then it had 2 added. So it's kind of like following BOMDAS. What were the steps that happened? And then to get to x, you have to peel through your layers of the onion. The first layer is that plus 2. So the inverse of plus 2 is obviously subtract 2. So we're going to do equivalent equations, and we're going to subtract 2 from both sides, because that way our answer will still be correct. Because if we only subtracted 2 from one side, it's no longer an equivalent equation. So the left-hand side will no longer equal the right-hand side. So 5x plus 2 take 2 is just going to leave us with 5x. And 32 take 2 is going to leave us with 30. So the next thing that we have to do to find out our x is get rid of that multiplied by 5. Sorry. And the inverse of multiplying by 5 is dividing by 5. But remember, we have to do it to both sides to maintain those equivalent equations. So 5x divided by 5 is just 1x, and 30 divided by 5 is 6. So therefore x equals 6. Now I would strongly suggest that you check all your solutions by substituting your answer back into the original equation. So in an exam situation, you could do all your exam questions and then come back and check your answers at the end if you've got time. So 5x, and we know that x is 6, so 5 times 6 plus 2 equals 32. So 5 times 6 is 30, plus 2 equals 32, and 32 equals 32. Yes, so we know that we're correct. So that's how we would solve those equations algebraically. Okay, so we've got a few examples here that we're going to have a go at solving. So we'll start with A. So A, we've got 2x plus 3 equals 4. So we're going to work our way backwards. So the first thing we're going to do, obviously using our onion method, is we're going to subtract that 3. So we're going to take 3 from both sides. So 2x equals 1, and then to get rid of the 2, we have to do the opposite of multiplying by 2, which is dividing by 2. So 2x divided by 2 is just 1x, and 1 divided by 2, is 0.5, or if you want to leave it as a fraction, you can do that as well. And then remember, you can obviously put that back into your original equation to check. So we'll check that. 2 times 0.5 plus 3 equals 4. So 2 times 0.5 is 1. 1 plus 3 equals 4. Yes, 4 equals 4. Good, so we know we're correct. Okay, our second one, we've got 5x take 3 equals 7. So we want to find x, that's our center of our onion. What's happened? Well, it's been multiplied by 5 and then 3 was subtracted. So we're going to peel our onion using equivalent equations and inverse operations to work our way back to x. So the first thing we've got to get rid of is that subtract 3. And the inverse of subtracting 3 is obviously adding 3. So we're going to add 3 to both sides. So 5x equals 10. Now we've got to get rid of that 5. And the inverse of multiplying by 5 is dividing by 5. So 5x divided by 5 will leave us with 1x, and 10 divided by 5 will leave us with 2. Again, we will want to check our solution. So 5 times 2 take 3 equals 7. 5 times 2 is 10. So does 10 take 3 equals 7? Yes, 7 equals 7. So we know our solution is correct. Okay, for C, we've got 5 take 2x equals 12. So we want to find x. What happened to it? Well, it was multiplied by -2 and had 5 added. So the opposite of adding 5 is taking 5. Now, some of you are probably thinking, Miss, you've done that wrong. That one should be add 5 because there's a negative sign there or subtract sign. No, the 5 here is a positive 5. If it was a negative 5, it would have a negative in front of it. But it's a positive number, so obviously it's been added on. So the opposite of adding is subtracting. So if we subtract 5 from both sides, we're left with that -2x equals 12 take 5, leaves us with, what's that? 7? Yep. Okay, so then we have to get rid of the -2x, and the opposite of multiplying by -2x is dividing by -2. Sorry, opposite of multiplying by -2 is dividing by -2. So x will equal 7 divided by -2. So in this case, I just leave it as a fraction. If you want to put it into your calculator, you can do so, and that will give you a number that you could substitute back in to check. But I'll just leave it as a fraction for this example here. Okay, for D, we have 6x plus 5 plus 4x equals 105. Now, before I get started, you can see I've actually got two variables. I've got two x's there. Sorry if I just hit that microphone, it sounds weird. So we're going to use our adding and subtracting of like terms to simplify it before we go ahead and solve. So 6x and 4x are like terms, so we can actually add those together to simplify. So we've got 10x plus 5 equals 105. So we want to solve for x. Remember, using our onion method, what happened to x? It was multiplied by 10, and then it had 5 added. So the first thing we're going to do is that inverse of adding 5, which is taking 5, which leaves us with 10x equals 100, and the inverse of multiplying by 10 is dividing by 10. So 10x divided by 10 is just going to leave us with 1x, and 100 divided by 10 is going to leave us with 10. So therefore x equals 10. Again, you can substitute it back into that original equation, check that you're correct. And our lucky last one, 3 equals 15 take 2x. So we want to find x. Again, it's been multiplied by that -2 and then had 15 added. So the inverse of adding 15 is taking 15. And we know we have to take because there's no negative in front of that 15, so obviously it's a positive 15. So 3 take 15 is -12 equals -2x. Now we want to get rid of the -2x, and the inverse of multiplying by -2x is dividing by -2. Okay, so -12 divided by -2, a negative divided by a negative is going to give us a positive, so that'll give us 6 equals, so -2 divided by -2, a negative divided by a negative is a positive, so positive 1x. So 6 equals x, or x equals 6. Again, substitute it back into your original equation to check that you've got the right answer. And that's all we have for today's video.